You're listening to the Azure DevOps Podcast, today featuring Steve Murawski on Infrastructure as Code.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to another episode of the Azure DevOps Podcast. Go online to www.azuredevops.show to see show notes and other episodes. I'm really excited today to speak with today's guest, Steve Murawski. He's a Cloud Ops Advocate at Microsoft, and Steve leads the Ops Advocate team focused on DevOps, SRE, and cloud-native scenarios with Azure. Steven is an active member of the Chef and WinOps communities and a maintainer for several open source projects, including Chef Habitat and Test Kitchen. Steve, welcome.
Hey, thanks for having me, Jeffrey. I'm really excited to be here and talk about a lot of fun infrastructure as code stuff.
Absolutely. So a lot's changed since the release of Azure DevOps Services. But before we get into that, what's going on in your world?
Well, so actually very recently, we've started focusing on adding focus to ops advocacy at Microsoft. And so for the past year and a half or so, we've done the developer advocacy thing. And I started about a year ago on Donovan Brown's team and was a developer advocate focused on DevOps scenarios. But my background is a little bit ops and a little bit dev. And so I fit really nicely into the DevOps space, but I tend to fall more on the ops side of the equation. And when we, as a team, had decided, hey, we need more of an ops focus, I started helping planning for building out some ops advocacy, and then came over to lead one of the teams on the with the ops advocacy focus. My team focuses on DevOps scenarios, so actually Donovan and I work extremely closely together, focusing on both the dev and the ops side of the DevOps story. We also cover site reliability engineering and cloud native type scenarios. We've only been around for a short time, so we're just kind of getting going, and it's really it's been a whirlwind of experience at Microsoft over the last year and a half.
And this is all new. So are you in Redmond?
No, I'm in Milwaukee.
Milwaukee.
Most of the team is remote. It's one of the more remote friendly teams at Microsoft, and so my team is scattered pretty much across the U.S. We've got some folks in Canada. We have some folks in Australia, and across the developer advocacy team, or advocates in general, we've got folks across Europe, and so we cover a lot of ground.
Yeah, so you know what a real winter is like.
Oh yeah.
Yeah, Redmond, great weather in Redmond. Of course, in Texas, we haven't seen snow in a while. So, but snow.
Yep. Oh yeah. We get a little bit of it every winter, and it's always nice going to Seattle and Redmond in winter because you can go around in like a sweatshirt and maybe a little hat because if it gets a little nippy, but it's like going to spring.
Oh, for sure. And when it rains, it's maybe misting a little bit.
Yeah. It's not nearly as bad as it gets cracked up to be. It does stay pretty overcast for winter, but
yeah,
everywhere's got their downside.
Well, here in Austin, Texas, it's just been raining for the past couple of days, and we are celebrating because we haven't had hardly any rain all summer, and it's been super dry. So we love the rain now.
So I was in Austin in May, and we did get a good bit of rain when I was there. In fact, I got pulled off stage because of a tornado warning.
Oh, gosh. But that was fun.
And in honor of talking to you, I'm wearing my Austin DevOps Days t-shirt. We got the DevOps Unplugged.
Yeah. We had the skull theme with the guitar on it. That was pretty cool.
Yep.
Well, let's get back to Azure DevOps. So we've had guests talking about the build pipelines and the 5 different areas of it. But you focus specifically on infrastructure. And so the normal use case is, oh, you have some resources provisioned and they're up and we need to deploy to them. But sometimes the infrastructure isn't there to begin with, right?
It isn't there, or it's there and it needs to transform in some way to meet the current requirements, right? And for me, I find that it's super helpful if we have the infrastructure requirements defined along with our application, so that when we go to deploy, right, that there, for example, if we're talking about just Azure resources, maybe we'll have an ARM template in the repository with the application. That means a local developer can, in his own Azure subscription from his local machine, take and apply that ARM template and spin up resources that are going to mirror how this thing is going to run in production. That means as my application advances through dev environment to test environment, release environment, or if you do like a ring kind of deployment scenario, whatever that scenario is, we can make sure that the infrastructure matches as we go along those environments. And we can provide some variability, like in some environments, it might be sized a little larger or a little smaller, but we've defined an interface being the parameters into our ARM template. So that's our interface for how we interact with the layout of the infrastructure, but we're keeping that same structure across things. And that also means that as I change my application, I can change the infrastructure to match its needs. Right? Maybe I need to add another function as a service, or I need to add SQL Azure, or I need to add a few more VMs, right? Because my service is growing larger and I need to add some additional capabilities. Well, we can morph the template along. We can build and test it locally to mirror our needs, and then validate that as we go through, as our end-to-end tests run, to make sure that things are behaving the way they're supposed to be. One thing, though, that we tend to leave off in our infrastructure as code talk is we can test that infrastructure as well. There's tooling, whether it's InSpec from Chef, whether we're writing some tests to go against the Azure API, whether we're writing some PowerShell to go and iterate over, or Azure CLI to go and iterate over our collection and make sure things are in the state that they're supposed to be in. We can externally validate that things got to where they're supposed to be.
You brought up something that folks might not be using so much, Chef, but as people are putting together their DevOps tool belt, which of these tools in infrastructure and ops management work the best for the Microsoft shops?
So that's a really good question. It's also really loaded, and there's a couple of different tool chains, and they all have their strengths and weaknesses. And so when we talk about building out environments, we want to look at a tool like ARM templates, right? If we're talking about raw Azure compatibility and what's going to have the broadest coverage across all the Azure services and capabilities, ARM templates give you far and away kind of the most coverage. Terraform is really, really popular with folks who are doing multi-cloud deployments or trying things between different clouds or doing some migrations. It also has some handy capabilities, and I know we've been investing a lot in the compatibility of Azure resources in exposure in Terraform.
Now tell people what Terraform is, in case someone hasn't heard of it.
Sure. So Terraform is a declarative configuration management tool. So we can define our infrastructure as code. There's a DSL for describing your deployment, very much like an ARM template, but a little different syntax. And it has some additional capabilities, something that you don't necessarily see in ARM, right? One of the things you can do with Terraform is it keeps a local state file of where things are. So you can kind of diff a potential plan versus what's actually deployed out in production. And so you can see what potential resources are going to change. It also has the concept of drivers. So you can point it at VMware, you can point it at AWS, you can point it at Google Cloud, you can point it at Azure.
It supports all the data center types out there, all the clouds.
It does. And now this is where things start getting sticky, right? Because you start saying, oh, well, hey, that's the thing I'm going to go do then, because it keeps things independent. But every cloud has their specific twist on services. They have whether it's a network security group or a web application firewall, or there's going to be some proprietary bits of configuration that aren't going to translate nice and seamlessly between things. And there are going to be some things that are just totally different between clouds or between deployments. Like you can't stand up an Azure Kubernetes service instance, for example, via Terraform in VMware, right? It's just, there's concepts that just don't migrate.
And everything's named differently. We've done significant Terraform implementations and we store them in source control and it's great, but there's no way that file could be run against AWS.
So for me, a lot of the value that we find in taking and defining our infrastructure as code is in the discovery. Right, regardless of the format the thing ends up, whether it ends up in a Chef recipe or a Puppet module or a desired state configuration document, a Terraform template or an ARM template, regardless of what format we've done some discovery work to figure out what our environments need to look like. And yes, there's not a lot of great automatic tooling to like say flip a switch and okay, hey, now your ARM template or can become a Terraform template, can go from Azure to AWS to Google Cloud. You can do that if you keep things to like the lowest common denominator across all the services, and you can reduce the amount of churn space you have. But you've gained so much insight into what your application needs to run that it's not a insurmountable problem. It might just be a hard problem to get these things to run into multiple environments. And there's a big difference in planning to do something hard versus something that is completely unknown. So I find there's value regardless of the tooling that you end up picking. There's going to be better tooling for better scenarios. You're in technology for any length of time. None of the considerations or very few of the considerations stay stagnant over time, right? The things that were limitations today are not going to be limitations tomorrow. The things that were limitations 10 years ago are not limitations today.
Right. Well, if we follow the 80-20 rule, probably 80% of the people listening to this are Microsoft shops, and most of them probably have a web application. They're using SQL Server. So if they have an application just as simple as that, even if it has hundreds of pages and whatnot, how do they get started in this infrastructure as code world and modifying their infrastructure on the fly?
Yeah. So if we're going to take like kind of the base scenario, I've got a web app and a SQL database. Let's get these things in ARM templates. And the easiest way to kind of start that, go into the portal, configure your resources so you're happy. And then there's a section in the portal that we can go look at there's an automation area. You can get a PowerShell script to set the thing up, or you can get the ARM template with a parameters file, right? And those give us a starting place then to go figure things out from. Now, the thing from the portal, we're probably just going to take and throw away at some point. So we're not talking about going and setting up your production environment via the portal. We're not talking about going and set up your dev environment via the portal. We actually want to, after we get that template, get it into our repository and get our release pipeline setting up those environments.
So I think what you're saying is that no one hand authors ARM templates.
I wouldn't. There are better things to do in life, right? You'll do some hand editing maybe, right? And there's tools in Visual Studio and Visual Studio Code so that you can more easily author these templates, find resources, assemble these things together. But take advantage of all of the cheats that you can to assemble these things, because it's a lot of JSON that gets thrown at you.
Right.
Take advantage of the quick starts. Right. Go look through on GitHub. There's an Azure Quick Starts that has a bunch of different templates and sample environments. There are a ton of different things that we can go and grab and just start working with, and then tweak from there. But before we start tweaking, once we've grabbed that, we want to get it into our Azure DevOps pipeline and start plumbing it into our into our release. And there are tasks out of the box for working with ARM templates. If you find they're not meeting your needs, you can always drop down to an Azure CLI or an Azure PowerShell task and provide the parameters that you want or the flow of work that you want. Or, hey, maybe there's just not an ARM template to do something. I believe offhand, this may have changed by the time this thing publishes, or I might just missed an announcement, but I don't think you can create an Azure Kubernetes service instance via ARM, right? But there's 3 AZ CLI commands that set everything up for you. So having a little script segment that will go and check, hey, is my Kubernetes instance there or not?
Yeah.
And then create it if it's not a hard problem. It's a simple shell script problem. But we get these things into our pipeline, and now our pipelines start enforcing our environments. And when things don't work, we're forced to fix the file that creates the environment, not go in and one-off fix the environment itself, because that's how we start seeing drift in our environments, right? If it's hey, I'll just manually go add this one web server or tweak this one config setting in development to make things work. Who says we're going to remember that when it comes time to publish? And it's not a manual publish, because now Visual Studio Team Services or Azure DevOps Pipeline Services is going to be mentally making that regex for a while.
Oh, yeah. That's right.
Right. We're not doing this hands-on deploy. And so we're not going to be there to remember necessarily to go and make that tweak in the next environment and the next environment after that.
And talking about tweaking, we'll pause for a word from our sponsor.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
All right, we're back. So we're tweaking our infrastructure.
We are. And so now we're talking about, as we tweak our infrastructure, our releases are deploying those changes, because we don't want to do them manually, because we're not going to remember to do them at some point, and that's how our environments drift apart. And we get those weird failures and the things that keep ops people up late at night, and then they call in the developers, and nobody's happy because it's 2 a.m. in the morning. People are a little bleary-eyed and looking over ARM templates and config files and code. It's just not a fun experience. So we try to minimize those opportunities for failure. We get our environment defined and we have it rolling through. But just like any part of our application code, when we make a change, we want to make sure it's a safe change. We want to make sure it's doing the thing that we expect it to do. And that's where applying some testing principles to our infrastructure as code come into play. And that's where having our environment, if we're spinning up something via ARM, we can also call separately the APIs in Azure to validate that the things that we expected to be spun up and the dependencies that we expected to be there and the config settings we expect to be there, that they're all present and accounted for.
Yeah, you said tests. What format do these live in? Were in-unit tests, X-unit tests, and where are they running from?
Yes. So it can be whatever testing tool is going, depending on who's managing the infrastructure. If the developers are managing the ARM templates along with, or if they've got an attached ops person, or if you have a separate ops team who's supplying standard templates, whatever that distribution tool is, there are tools like Inspect from Chef. There are tools like Pester, which is a PowerShell testing framework, the NUnit or XUnit. All of these things, we have ways to call into Azure. Whether it's I'm writing some code around the Azure APIs, I'm using Azure PowerShell, I'm using Azure CLI, I'm using the Ruby SDK in the case of Inspect, right? There's a number of different ways that we can call in, and we're writing tests, which I actually think are slightly more important to do against our infrastructure, because our infrastructure is all about side effects. Right. And so when we change our infrastructure, we're changing something physical in the environment, or, as physical as electronic resources get. But we're changing config settings where if we're talking about a virtual machine and we want roles and features installed on a Windows VM.
Mm-hmm. Yeah.
If I say install IIS, more than just IIS gets installed. There's a handful of sub features that get installed with it. And when I uninstall one of those sub features, sometimes some go with it, sometimes some don't, right? And there's not a perfect rollback necessarily. So we need to be able to make assertions against whether it's our Azure environment or the VMs that we're running in or the PaaS service that we're running on, and make the assertions that the config settings that matter to us are present and the things that are harmful to us are not. And none of this stuff crops up kind of like all at once, right? It's not like we have to go think back to like Michael Feather's book on working effectively with legacy code.
Mm-hmm. Great book.
You're not going to go back into this old C application and write tests for everything that's already there already, right? You're going to focus on the thing that's causing you pain, that either the feature you need to implement or the place where you have a bug to fix, and you're going to start extracting stuff and writing some tests around it, right? The same principles apply to infrastructure. The difference is, rather than like unit style tests in infrastructure, we tend to focus more on integration tests because, again, we're talking side effects and validating the side effects. And this is one area that I think when you see people who have invested in the infrastructure testing side of things and have that integrated into their pipeline, there you start to see increased reliability, increased responsiveness to change. And it's less of a kind of YOLO, you only live once kind of thing. Like, let's just make this change to the ARM template and see how that blows up the environment. Because we've taken a test-driven approach to, I need to change the environment specifically to look like X. And I validated that this change will make it do that. And so I have a higher degree of confidence as this thing rolls through my pipeline that it's going to make the changes I expect it to make.
Well, that's awesome. I can see huge benefit from that. Now, you're storing these ARM templates, for example, in source control. You're generating the first ones from the Azure portal themselves. What level of granularity do you break up the ARM files? Because on the one extreme, if you have one file for everything, website, maybe your backend batch job, SQL Server, then you have this really large code file. So what's the mechanism that you break it up so that you do have like C# classes? We put one class per file. What's the corollary in ARM?
So you can do nested templates in ARM. This is an area I'm still kind of battling around what the ideal is there, because it becomes trickier to troubleshoot when you start combining ARM templates, and becomes trickier to figure out what's actually going to be a valid ARM template and how it actually applies. So there is a maintenance overhead to stepping away from kind of that one large ARM template. But if we're also seeing this one large ARM template, maybe the size of the service that we're deploying might be too large, right? Because this thing's sitting alongside of our application, and maybe we have this big monolith application that we need to define all the things in one place. Well, if that's the case and that's where we're going to stay, it's going to be worth the time to look at how we can refactor our ARM template. This is, again, where these tests come in really important, because now I can refactor with some freedom. Mm-hmm. Because in my refactoring, I shouldn't be changing the outcome of the ARM template application. I should just be changing the structure of the files for maintenance. And maybe simplifying things, maybe finding common things where I can parameterize them a little differently. But my outcomes should remain the same. How do I validate that? Well, I have to have some tests. I have to have some testing in place to do that. Mm-hmm. So if we have the testing in place, how specifically and how narrowly we break up our ARM templates, and to what granularity, that's what's going to enable that. And that's what allows us to get to a point of maybe, this is an environment that does not change very long, and it's not painful to have that one big ARM template. Mm-hmm. And the amount of time and effort it would take to get to a place to safely refactor that thing isn't worth it, right? We have to be able to make these trade-offs and discussion. Like, there's the ideal, and then there's the world that we live in every day.
So most people are going to have one ARM template for their application then, just the way that ARM is architected.
I think that's in large part how we start. Now, if you have a strong central ops team who is acting as a service provider and providing custom templates out and has time and resources to, effectively segment those things out and has them wrapped with tests and things like that, well, maybe we're not going to see that. A lot depends on what the scope of the problem is and the pain that's being caused, right? Again, we can talk about ideal all we want, but at the end of the day, we have to approach it from a practical perspective of, all right, am I going to be changing this thing often? And if I am, okay, now this is a pain. Let's take this as an agile thing. Let's get it as a work item in our backlog. Let's get this as a theme for an upcoming sprint or something, right? Where we have our config management is painful. Let's solve that and approach it just like we would any other problem in our application.
And configuration management is painful. I mean, provisioning is one thing, and when you have nothing and you're going to something, that's one problem set. But then once it's been running for a while and you say, oh, you know what? Let's not have the entire application behind the password and authentication. Let's have just one URL for our IT monitoring tool able to go in there without doing it. Or I need to scale it up, or I need to change something. So once it's been running for a while, what does that path look like to change something that's already there when you don't want to blow it away?
Right. So that comes down to how these tools modify the environment. And ARM has a couple of different modes that it can operate in. One is I will make this environment look like me and remove anything that doesn't. Another is more of an additive model, right? And there's pluses and minuses to each of these things. And in some cases, we might say, hey, we need to completely refresh and we're going to rip it down and start something brand new. In some cases, we need to be a little more kind of circumspect about how we approach those changes. Now, if we are managing our change along with our infrastructure along with our application, and we start to see some scale up, scale down, some of these things are going to be runtime toggles, right? Like a scale up, scale down scenario, that might be something that we want to have the capability to do from outside this process, right? That's one of the variables that we're going to tweak. We might start at a certain place, but we might want to be able to scale up, scale down. And so those are things that we're not necessarily going to ship a new build to go do. Those are things that we're going to either look at something in the portal, or we're going to have some custom management UI in front of to go and dial up and dial down the environment to where it's going to be. To add new services, now that's something we're significantly changing the composition of our environment. And so we're going to want to include that in our ARM template. We're going to want to have tests around that, and we're going to want to run that through our build pipeline. So there are different tactics that we're going to take and different approaches that we're going to take based on what we're trying to do. So scale can be one thing. Maybe we have auto scale. Maybe we're scaling on certain metrics and things that are tied to the application. And we don't want to have to release a new build just to scale something. We want to have that separate from. And those are toggles that we're going to learn about by surfacing this stuff as infrastructure as code.
So you said not produce a new build of the software just to change something about the environment. So does that manifest itself in a new build configuration in Azure DevOps Services that doesn't compile the application?
Well, so what that might be is if we have hard-coded in our template how many of X resource, like if I've got a count of 4 for it that's hard-coded into my template, if I want to scale up or down, I have to release a new build. So maybe that's something we parameterize. And then maybe now we have a management UI or a set of management scripts. Somebody's got a PowerShell script or whatever to go and throw a new parameter at that particular template to scale up. Or I'm using auto scale groups, and now I have a different interface for being able to, or VM scale sets or something, right? So I can scale with a different interface and something that does not require a build. Now I'm going to go drop in, if I'm going to add Cosmos into the mix, right? Now we're looking at changing the environment itself. Not necessarily, we're not talking about like numbers of things. We're talking about types of services and the layout.
It's a brand new service.
Right. And so there we want to change our config management in our application. We want that to go through our build and deploy process and roll into the environments and go through our testing, and not necessarily, we don't want that to be a runtime toggle. Right.
Gotcha. Okay. That makes sense.
So you can kind of think of it like feature flags, right? I might have a feature flag to enable and disable certain behaviors at runtime. I don't release a new build to toggle a feature flag, right? I'm going to have an admin UI, or I have an API to go hit, or something like that. It's that same type of thing, right? We've already shipped the structure of the application. We're not changing the structure. We might be changing the amount of things. In the case of we are changing the structure of the application, well, that's something we want to have a build for.
So do we push a new release through the release part of pipelines with an existing build, perhaps?
Yeah. So if you are just changing the infrastructure, that's probably unlikely. Because if I'm adding some component to my environment, I probably have some part of the application that needs to exercise this, or it's part of a series of changes, right? Maybe I want to make sure that bit of infrastructure is there, and then subsequent application deployments are going to roll out, right? How we actually partition our build and release process is super customizable. And where we don't have toggles in the application, we have toggles in script resources, right? Because at the end of the day, you can always fall back to script, and you can say, hey, did anything change? I can look at the Git commit history, for example, and say, did anything change in my application portion? Yes. Okay, great. So we're going to go this route and make sure we build a new version of the application. Hey, did anything just change in no? Okay, great. I'm not going to build. I'm going to move on to my infrastructure portion. Did anything change in infrastructure? Yes. Okay, great. Now we're going to go and do this set of things. And
cool.
Then we can roll into our release pipeline, but we're keeping them alongside. And so that when we look at a particular version of the application at a point in time, we know what the infrastructure looked like at that point in time.
Got it.
And as we evolve the application, we evolve the infrastructure. At some point in time, we might have evolved the infrastructure to have more things than what the application is using. That's just like having a class in our application that has not been pulled into anything yet, right? That's under development. It's maybe sitting behind a feature flag, but we have our pipeline that keeps releasing things, and we want to be merging to master regularly. So maybe we have changes that aren't necessarily leveraged yet. The downside of this, right, if we're not planning to use those resources relatively soon, is we're spinning up resources that we're paying for until we
right.
So usually you'll see an application change that uses the resource that we've just added.
Okay. Well, this stuff is so new. 5 years from now, we're going to have all kinds of best practices and samples and templates to drop in. I'm sure everybody's looking forward to that. Now, you are also a really active member of the Chef and the WinOps communities, as well as a maintainer of some open source projects. Can you tell us a little bit about that?
Sure. So I'll start with the WinOps community, right? So the WinOps community is a group that grew out of a user group in London. It's a bunch of Windows systems admins, primarily some developers, who tend to focus more on forward-leaning management practices. So a lot of automation, a lot of scripting, really into this DevOps thing, really into site reliability engineering concepts. But a lot of the stuff that happens in those communities tends to really focus on the Linux platform. And so the WinOps community kind of grew up in like, hey, we're Windows folks trying to do this stuff too.
Yeah.
So it's just kind of a community to kind of help nurture those folks who want to go that route, and folks who want to look for other pattern and practices for people who've done it on that particular operating platform. So there's a conference regularly once a year, and there's a meetup. Those are in London. There's an upcoming event in October in San Francisco, along with the Chocolatey. So it's Chocolatey Fest / WinOps San Francisco.
Yummy.
I mean, that's been kind of near and dear to my heart. I worked for Chef for 3 years and maintained a lot of open source projects while I worked there. Worked in the open source space. And so I've been active in the Chef community, spend a lot of time at Chef events and Chef Slacks and things like that. Chef is a suite of things, but the core thing there is a configuration management platform, and it works really well. Windows, Linux, got a great ecosystem of testing. That's one of the things that drew me in, is the focus on testing, and a really great community to be involved in. And I got to spend some time at ChefConf earlier this year, and just a wonderful community, a really good mix of Windows and Linux folks across that space. And then the open source projects I've been involved in are really around the infrastructure automation space. Chef, as we mentioned, I've done a lot of work on Chef around usability on Windows and its integration with PowerShell and desired state configuration.
Would you say if people are using VMs, then they should be using Chef? Or does it go with DSC, or is it instead of DSC?
It's a with, right? So,
Okay.
So Chef can use any DSC resources natively. And there's ways to actually embed snippets of desired state configuration syntax into a Chef recipe. I think Chef is the best way to experience desired state configuration.
Mm-hmm.
I'm a little biased in that regard,
No.
having worked there. But I also had the first production deployment of desired state configuration ever. I was a site reliability engineer at Stack Overflow. And when desired state configuration came out in beta, I was rolling it into production. And I spent about 9 months kind of implementing that deployment and managing it over time before I went to work for Chef. And I know firsthand what some of the pain points were in working in desired state configuration. It's a wonderful platform. There's a lot of ecosystem tooling and patterns that don't exist that Chef helps provide. So it's really like this just nice jumping off point. Like you can take advantage of a lot of stuff in the desired state configuration ecosystem and get all the benefits of the Chef ecosystem on top of it. And it makes for a very nice thing. Puppet also has decent integration into desired state configuration. If you're doing VMs and using some configuration management, whether it's Ansible, whether it's Puppet, whether it's Chef, whether it's desired state configuration, I'm not going to be mad at you anyway, because you're already kind of in the top, like 15% of folks who are doing anything about it. I tend to think Chef works really well because it matches my mental model, but there are other good platforms as well.
Well, and our listeners are looking for the ones that work the best with Windows because, the Linux ecosystem, there's really good tools for there. But all the software is Visual Studio based going back, 10, 15 plus years. And so these companies that are Microsoft stack through and through, it's good to know that Chef works really well with DSC and the other tools that work really good with Windows, even if they did originally come from the Linux side.
Yep. And then Test Kitchen is very near and dear to my heart because this is like the infrastructure testing tool. It's a test harness, and it allows you to wire up a way to provision a virtual machine. It could be a cloud provider, it could be VMware, Hyper-V. There's a number of different options. A method to apply a configuration that could be Chef, it could be desired state configuration, Puppet. The tool came out of the Chef ecosystem, but it's pluggable. So you can use a bunch of different types of configuration management tools, and then a way to test those. And so if you follow a convention that's defined about where you put your tests and all, you can basically put together a little config file that Test Kitchen will follow, and it will spin up an environment and apply those configurations and run your tests. Where this gets to be really powerful is I can specify, I could have some in Azure, I could have some in AWS, I could have some on-prem, I can do it locally, I can do it in cloud, but I can also specify multiple like platform types. So I could have Windows 2008 R2, Windows 2012, Windows 2016, Windows 2019, and I can apply the same configuration across all of them, run the tests, and validate that those things work across all those different environments and find out where I have problems. It makes it a lot easier than when we start talking about migrating from operating system to operating system. Or I want to go from AWS to Azure or Azure to Google Compute, right? I can just swap out the driver and I can see how these things behave differently in different environments. And so Test Kitchen becomes a really handy tool in the infrastructure testing space. And for testing, I can do InSpec, I can do Server Spec. Those are a couple of testing frameworks in Ruby. You can do PowerShell with Pester. There's a handful of other test tools, and it's an open interface so that you can, if you don't find the tool you want, it's really easy to write a little wrapper around to get a tool that you want to use integrated.
So Test Kitchen, is that C# based?
It's Ruby.
Ruby based. Okay, gotcha. So as we wrap up, how can our listeners get going with infrastructure as code? Are there any samples or public projects out there?
Yeah. So actually, Donovan Brown's got a project called Yo Team, and in Yo team, any of the application that helps you scaffold out a build pipeline in VSTS or TFS for a number of different languages and platforms. So .NET, Java, JavaScript, bunch of other stuff, right?
Nice.
Every build pipeline that scaffolds out includes the ARM template to build the infrastructure.
Mm-hmm.
It's a great way to take a look at how do I integrate some infrastructure as code into my build pipeline. Now that's just step one. There's not like a bunch of infrastructure tests or anything with that, but that gets you started with how does it look to have infrastructure as code along with my application. Going on from there's some great active discussions in the Chef community Slack. There's always stuff happening on Stack Overflow or Twitter things for that. Docs.microsoft.com has great resources around ARM templates and the Azure CLI. And I'm going to guess there's probably going to be a few good sessions coming up at Ignite.
Are you going to be there?
I will be there.
Awesome. Me too.
Yep. Awesome. Great. We'll have to meet up in person.
That would be great.
But I can, if you look through the Ignite session catalog, there's going to be a handful of good sessions around ARM templates, and all of those will be available for streaming on demand as well. So watch what develops in the learning space very closely.
Awesome. Fantastic. Well, thanks so much, Steve, for visiting with me. It was great.
Oh, it's been an absolute pleasure.
And until next week, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.